Hello, welcome to my talk. It's called Don't Yield to Unknown, Pull the Power of JavaScript Generators. And if you don't get the pun yet, that's no problem. That's why I'm talking tonight. So my name is Max, and to show you a little bit about myself, I'm a software engineer. I'm also tech evangelist, which is a very fancy word for the companies paying to do the talks, which is super nice actually. I'm currently learning Swedish, so låt oss prata svenska. If somebody speaks Swedish, let's talk. And also I'm a big tech nerd, and that's why I also enjoy talking on meetups, and I hope you'll enjoy my talk. But first, a little story time, because why do I do this talk? It's obviously about generators, right? So last September, I was at this super nice meetup in London called Future of Coding, and it's very, let's say it's very different. People are doing very weird stuff, and I had a lot of cool discussions about tech and about philosophy and so on. It's a lot of tech talks. And sorry, I have to do one more thing because I have to unskip a slide. Okay, so here, story time again. So I was in London, and there I was talking to this nice guy who is called Bernhard, and he's one of my best friends, and we were talking about tech stuff, and I was telling him about some problem I had and some weird solution I did, and he just asked me, yeah, why don't you use generators for that? And then I was like, yeah, I can just use promises and, do some, function that returns me a promise. And I explained very weird stuff. And then I felt like in this meme, right? So it's like, why don't you use the full potential of JavaScript? I can't just use promises. And it's like, function, generator. And I was like, you're scaring me. So yeah, the question is, why aren't we using generators, right? So I want to do a little experiment with you guys. And the experiment is, I just ask you some questions and you just show me, show of hands, right? So who knows promises, right? This should be like everybody, right? Who regularly uses promises, yeah, also, and who is comfortable using promises, right? Right, so again, let's do that again, right? Who knows generators? Generators, yeah. Who regularly uses generators? Oh, some hardcore people over there. Ooh, but that's a good use case actually. And who's comfortable using generators? Right. So it's very interesting, and when I did the research for my talk, it was also very interesting because I tried to really search for the reason why people are afraid of generators and not using generators. Also in my workplace, when talking about generators, people are like, yeah, generators. I know them, but I don't use them, right? For what? And so I did some research on the internet, and if this is like Google Trends, and it doesn't even pick up, right? So it's very low. Like the search for generators is almost non-existent. And also, if you scour Reddit, people will ask, where will I need to write generator functions? Does anyone use generators? Why? Yeah, you have a question?
On the previous slide, what's the blue line?
Promises.
The blue line? Yeah, sorry, thanks. The blue line is JavaScript promises, and the red line is generators. And that's actually a good thing. I have this talk tomorrow as well, so I can edit. Thank you for the tip. I also searched Reddit, and people were not sure if they should learn it, use it, what is it used for. And and then also there's this super neat website, which I can just recommend to anybody. They have developer roadmaps where you can basically go there and put in any topic like JavaScript or React or something, and they will give you a full journey what you can do to know more about the topic. And it's actually pretty nice. And this is the JavaScript journey, right? And on the bottom somewhere there's iterators and generators. So it's in there, but it's very on the bottom, right? So the question still remains, why aren't we then using generators? So In this talk, I want to level up your generator game, so to speak. I want to take away your fear of generators. I want to show you the power of generators. And also, I want to show you when to use generators. But first, we are currently on level 0 though. So the next level needs some basic facts before we can level up. By the way, I really love the color. If you know it, it's pale violet red CSS. It's just best color ever. That's why I use it here. Just a side note. So basic facts, right? Generators were introduced with ES6, which is also ES 2015, which is super confusing, but it's the time where promises were added, classes were added, generators were added, the spread syntax was added. But it's not the time where async await came. That came with ES 2017, which I don't know the number, or was it the year they changed to year numbers for good? It's confusing. Anyways, generators came with ES6. So also a very important fact to know that before we can level up is to understand the difference between push and pull based approaches in programming, right? So it's like these doors, right? We humans, we always struggle. Do I like pull it? Do I push it? It's don't pull, push only, don't push, pull only. Not sure, but let me elaborate. Consider this code for a second, and I'll let you look at it a little bit. It's basically a made-up SDK, and it calls a sample JSON API. And I'm doing then, and then I'm just logging the users. So, show of hands. Who thinks this is a pull-based approach? And who of you thinks it's a push-based approach? Oh, so not
Can I say pull, push and then pull?
So, yeah. Actually, it's kind of both, right? But if we are speaking of the context of promises, it's push-based. Because promises, if you say to if you do an SDK call, you're telling the program, do this, and when you're finished, call me, right? So the promise is pushing the thing to us, right? And like you, I tried to ask an LLM if it can tell me if this is pull or push based. And it's very, very, very hard to read here, I'm sorry. But the LLM basically said, oh yeah, this is obviously pull based, right? Because you're pulling the value out of the SDK. And then I said, no, it's not pull based. It's promise, it's push based. And said, oh yeah, I'm so sorry. Of course, you're right. It's yeah. So basically, we taught machines to be as stupid as humans, right? So great. So yeah, and if we have the generator example, it's basically, we can say this is pull based because I, as the consumer or as the programmer, am deciding when I get the next value, right? So I just call .next, and I'm telling the generator, hey, I'm ready now. I take the next value. So that's the very big difference between pull and push based approaches. And with generators and promises, it's as follows. Promises are, of course, push based, because they will push us the value when they are ready. And with generators, it's the other way around, right? We pull the value once we say, okay, I'm ready now to consume the value. So it's all about the consumers. So, and with this, we are ready to get to the next level.
Is async await these promises also push-based?
Yes, it's just async await.
It's just synthetic sugar.
Yes. But we will get to that. We will get to that. We will get to that. So, but now we are getting to the next level. So, congratulations, we reached level 1, right? Woo! So, woo! Nice. So, this makes us eligible to see actual code examples. So, let's consider this very, very simple generator here. Let's walk you through, right? So, we have a simple generator, and you already notice. This is like why I think developers are scared of generators, because you have this star here, and then you have this weird word which is called yield, and it's doing something, and it kind of looks like a return, but then it's also not a return because you can have it multiple times in the same function, and it's weird. So how do we do this? We call the generator, and then what we can do is we have an iterator, and we can just call next all the time. And in the example you see, every time I call next, I get the next value, which is yielded from the generator. Okay, fair enough. So there's a couple ways you can get around calling that manually. You could, for example, create a while loop, which is also so to say while result is not done, we will just call next all the time and get the values out. But there's also something you can do. You can create an array from the generator, and you can just call the generating function from the array prototype and just pass the result of the generator function. And then you can log the values, and it's just a normal array. So, but why does this work? I can call a generator, and then suddenly it's an array. That's weird. Cool. It's cool, but why does it work, right? It's very important to understand that generators actually return iterables, or do you say iterables? Iterables. Thank you. And it's just a fancy word for it's an object which contains a value and contains two props. The one is value and the other is done. So if the value is defined and done is false, of course, it means that the generator has more values for us. And with the done property, we can make sure if the generator is done yet or not. And also, JavaScript does this with a very simple trick. If you have any object in JavaScript which implements the symbol iterator property, and you implement it correctly, you suddenly have an iterable object. So any object that has this with a valid implementation is iterable, which is super nice because then suddenly you can do cool stuff, right? I can create an array from my simple generator with calling array.from. I can just spread it, which is also like pretty cool to just spread the generated values. And you can also use for off, but I don't know who wants to do this. But yeah, you can do that. So, but wait, there's more, right? So now that we're level 1, I thought, we can do a little bit crazier stuff as well. So in this example, we are doing something which should ring a lot of alarm bells, right? Because we have this generator and with a value, and then suddenly we have a while true. Oh my God, it's while true. It will crash our program. Oh my God, yeah, it's very bad. You shouldn't do this. Don't do this at home. But with generators, actually, it's fine because we have this yield value here. And as I told you before, with generators, we tell the generator when we are ready to consume the next value. So the generator will just sit there and do nothing until we call it, which is nice. It's pull-based, so we can do that in that case. And also, when using this generator, it's the exact same thing as before. We have an iterator, and we just call next, and then we get some values. But now you will ask, what happens if I spread this now? Then you will get a Stack Overflow, of course, because then you trigger the while true, right? So you shouldn't do that. I just wanted to show you that you can have endless generating stuff with generators if you know how to use it, right? Yes?
Can I yield 2 items in this while true? For example, yield the value plus equal 1 and then yield hello? What happened then?
What do you mean exactly? Because in this case we can only yield numbers because it's only returning the.
Okay.
It's
Can I?
JavaScript. You can
Yeah.
yield the string.
Yeah, you can yield anything. Yeah.
Can I yield 2 items? So.
You mean like
two
on?
yield statement in a while true?
Yes, you can. But then every time you call next, it will first yield the first and then wait. And then it will yield the second value. So it will always, when you have a yield, it will always stop the execution at the yield keyword. You can have as many yield keywords in your generator function as you want.
So
Yes?
if I have this yield, which we see now, and then I yield string hello, then I have one hello, two hello,
Yes,
three hello.
yes, exactly.
But not with one next execution.
No, yeah, you need to call then next
For
2
each
times.
next I will
Yes.
have one, and next
So
is-
yeah, yeah. Next, then it's 1. Next, then it's hello. Next, then it's 2. Yeah.
It's also yielding a function.
Yeah, we will come to that. But we are on level 1, so please, it's.
When I call generate IDs, is the code run until the first yield? Or is it
We will come to that. Let me continue. But it's good questions. Good questions. It's yeah. So so why does this work actually? That we can have a while true is we need to understand the difference between hot and cold, and or eager and lazy. So I did a little experiment again. Consider this promise code, right? I let you look at the code again for you see the sample SDK thing again, and then we do something, and then later in the code, I await the promise, and then I log the users which come out of that promise. And now, show of hands, who thinks that the promise is actually executed at 1? And who thinks that the promise is executed at 2? So yeah, it's the participation is very low. Like when is the action of the promise fired? When is this is doing an HTTP request? When is the HTTP request fired? I'm gonna do the poll again. Who thinks it's 1? Yeah, and who thinks it's 2? Okay, so actually that's a very neat thing to know about JavaScript. The promises are very eager. If you define a promise, yeah?
What does the AI say?
We could do a demo, but no, it's better not to ask it. But that's a very neat thing to know about JavaScript. If you have promises, the time you instantiate it, it will immediately start working on the promise, right? So if you call that function, even though if you're just awaiting the promise somewhere else, it's already running. So it means that the execution is immediate, and we can say promises are eager. So which is the complete different to generators, because generators are lazy by default. They are super, super lazy. And we had the question already. There's this code example again, where we have this simple generator, and then we call the generator to get the iterator. So does the program show I was executed? Because we have this console log here. Who thinks it does show it? Do you think it shows the console log? Because I'm calling the function down there. Okay, so, and who thinks it doesn't? Yeah. So it's actually really, it's a big catch also, and a very big caveat of generators. The generator is not executed until you call next the first time. And there's even wrapper functions which get around this, because you sometimes need some setup code here. But until you don't call next at all, it won't execute the generator function at all. So this console log in this program is not executed.
Do I get
So
an error when I do that? Or
no.
it's just-
No, it's just not doing anything. It's just sitting there, and it's like, oh,
Just let the value 0 and then that's it.
I'm not called, so I won't do anything. You know, it's very lazy. Yeah.
This seems to me like it's just a sort of syntax sugar for instead of having like a file with a closure or a variable that's not.
Yeah, you know, that's also what people do. They have like functions, they return some functions which are lazy functions with then, you know, and you can just use generators for that. It's like my friend said, why don't you just use generators for that? So yeah, that's basically what he meant with that. And with that knowledge, we can get to the next level. Woo, we are level 2.
Yeah.
Very nice. And so now that we know that generators return iterable objects and are executed lazily and are pull-based, we can do some cool generator stuff. So I thought very hard about what examples to show you. And I also found some cool stuff. So let's directly go to the first example, because we are on level 2 now, so we can do cool stuff. Consider this transform function, and don't worry, I'll walk you through again. This transform function takes an iterable again, and it also takes a transform function. And the only thing it's doing, it's iterating over the iterable, and it calls the transform function for it and yields the value. So what does this mean? I can call transform, I can give it an array, and then I can give it a transform function. But Max, you will ask, we have map, why don't we need this? It's why do we need this? It's completely irrelevant. But the cool thing about this map function is that it is only executed on demand. So imagine if you have a very, 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 very big array, like thousands of elements, you can execute the map function for only as many elements as you allow to pull, right? So if you say, I'm gonna pull 5 elements at a time, and then do something with it, and then pull the next 5 elements, it will only do the function for the elements you pulled out of the generator. And of course, this is a very simple example, but imagine you can do some very computation heavy stuff with this. So yeah, I thought this is a very nice example. Also, a very nice thing to know is, I told you generators came out when ES6 was released, so promises were there, but async await wasn't. It came later, it came in 2017. But Babel there was a Babel transform actually, where you could transform async await already and use it in your browser. And it's actually very simple how they did it. So there's a function which is using async await. And it looks very simple. We await get users, we await get users by post ID, and then we return the data. What if I told you that you can easily do this with generators? Here in this case, if we are comparing the two code pieces, it's actually, there's no difference, right? It's very similar. The only thing that is different is this generator initiator function, which was back then injected by Babel, and all the await calls were just transformed to yield. And I will quickly show you the generator initiator because it's not very complicated. By the way, if you're overwhelmed by this code, at the end of my presentation, I have a QR code with a GitHub repository, and if you're interested, you can just go there and look at the code and play with it yourself. So just bear with me here, just go through with me, and yeah. So generator initiator, what it's doing, remember, we need to wrap our generator in this function. So the only thing it's doing, it's taking a generator function, and then it's creating the iterator, and then we have this recursively executed executor, which is just doing, hey, is it done? Like we were getting the iterator again, and then it's saying, hey, are you done? Then return the value, and if it's not done, value.then, and it calls the executor again. So it's recursive. And you don't need to like fully understand it right now, but it's just a very neat function that it's also simplified, of course. The Babel transform is more complex, and that also does error handling and so on. But this is a very neat way how you can transform async await to just yield, and with generators. And this is the way how they did it. And also, now that we are on level 2.
Quick question.
Yeah?
Would that then be lazy?
It's basically the same behavior as async await. So async await is just syntactic sugar for you're awaiting a promise, and in this case you can model the control flow of async await with yield and generator functions, because it will just pause until you get the value back. So it's just people back then, before async await came, people used to model their own async await they knew from C# and so on with these functions. So they also did it themselves. So, but now that we are on level 2, we can, also talk about a little more advanced features. So, what if I told you that you can yield generators inside generators? Yeah, Of course you can, right? No problem. May I introduce you to yield star? It's some syntactic sugar which lets you yield other generators inside generators. But what it, like, to make it more understandable, what it actually does is it iterates over iterables. So in this case, we have a number generator which takes an array of numbers, and we just say yield star numbers, and the only thing it's doing is every time I call next, I get the next element of the array. So what it's doing, it breaks the array apart to its single values. So the yield star numbers is transforming the array to like each part of the array. And it works with every iterable. That's also why if you have a string called wow, then you can break up the string into its characters, because every string in JavaScript is iterable. And if you iterate over it, you get just every character of the string. So you get WOW if you call the iterable 3 times. But as I told you before, you can also yield other generator functions. And yeah, now it gets complicated because we have our misc generator, which is then yield starring the get number generator and then yield starring the get characters generator. And because this is in turn again returning an iterable, I can just do the spread function down there, and then I will get, you know, 4, 2, and then the smiley I put in, because it breaks apart all the things. And with yield star, you can yield other generator functions. And this is this knowledge is important for the next examples. Yes?
You don't need the next because you spread it?
Yes, that's correct. So you can either manually control when you get the next value, or you can defeat the purpose of generators again and just spread them. Yeah, but for demonstration purposes, it's easier. Yeah. But yeah.
There will be no spaces between 4 to...
Yes, there will, because if you put more arguments inside console log, it will automatically put a space. So that's a JavaScript pro tip. And there is one last thing before we can level up. Of course, there is async generators. Okay, bear with me here. It's a lot of information, but as I said, the whole code is on the GitHub. You can just look at it later if you want. So of course, you can make any generator function async by just putting async. And what does this do? It enables you to await stuff in your generators, which is very neat, because then you can do async stuff in your generators. And then afterwards, if you successfully awaited it, of course you should do error handling and stuff, you can yield the value. And then how do you actually consume the values? If you don't use third-party libraries, you sadly have to use for-await to iterate over the async iterables. But there's a lot of libraries which allow you to consume the async iterables more easily, like RxJS or Effect.js. But we will come to that later. And with that, it's time to go to the final level. We are on level 3. Nice. You're still with me. I know it's a lot of information, but now we get to the neat stuff. So now that we additionally know that generators can yield other iterables or generators and can be async, we can dive into actually some more practical examples. And one example which I had to do at some point in my work is efficient file processing. Because what I ran into back then, I wasn't using any third-party libraries. I was running into back pressure, which means I read in more lines of code, more lines of the file than I could actually process at the time. So I had a back pressure, which then filled up the memory and so on, and it was bad. So to avoid this, we can use generators. And this is a lot of code again, but I walk you through. you can give it a file path and you can tell it how many lines it should read at once. So you can just throttle the amount of lines it will read until it waits till you are done with your processing, and then you can tell it, oh, give me the next 10 lines. So you will never overflow from the producer, right? So it's very, I abstracted it away a little bit. You get the file reader, and then you have this reader. You have your line buffer, which are the actual lines that you're currently processing. And then you are awaiting the reader, which just loops over the lines. It reads it, and it needs to be async as well, because the reading of lines is async. And then it just yields us the lines, right? If we have the maximum amount of lines, it will tell yield. And then we have, like, if we tell it always do 10 lines, we have our 10 lines, it yields it, and it will wait until we get the 10 lines. And if we are done and we tell it, get me the next lines, then it will get me the next 10 lines. And of course, we cannot forget about yielding the rest of the lines if the maximum number of lines doesn't match up with the lines of the whole file, right? So it would look like this. We are generating our iterator or line generator, and then we can just for await loop over the async iterable to get our lines and then do stuff with our lines. But I told you, if you're using third-party libraries, it's a lot easier, because then, for example, RxJS, you could do stuff like you just call from on the process lines, and you can just pass it an async generator. And if you do that, you can just subscribe to the observable, and also observables are push-based. So it will give you the things, and you can just always only do the 10 lines, right? We configured before. Another handy example, actually no, observables are, now I confused myself.
They are push. They are push because they're pretty much like promises.
But you're subscribing to it, but it.
Yeah, but it pushes.
Yeah, right. It pushes you values. Correct.
It's
correct.
just like promises.
I almost confused myself here. So thanks for helping me out. Another handy example is handling pagination, for example. And I also had to do that at some point. We know pagination is very important at our APIs, but sometimes I just want to get all the things there are on the thing. So you need to write functions, we then check, is there some next page and so on. And there's just a very neat way you can use generators for this. And this is the biggest code example, I promise, and after that we're done. And I will walk you through again. Of course, we have this async generator functions, and we can give it a repo name, and we can also give it the maximum pages it should iterate through, because otherwise it would just do it endlessly, and we don't want to, nuke the API, right? So, and then GitHub has this very nice API. You can ask it for commits from some repository, and we're tracking the current URL, which will change, because when we have the next page, we need the next URL, and also the current count of the pages we are going through. So we have this while loop, which loops over the pages. And because this is a generator, it's very easy to do the control flow, because I'm fetching the URL first and converting it to JSON. Then I'm looking, hey, is there a next page? And with the GitHub API, it's a little weird. You need to do some regex stuff, but believe me, it works. And if it finds the next URL, it will just save it. And then at the end, this is like the cool part, you can iterate over the commits of the body and then just yield the commit, right? So you're just yielding all the commits, and it will automatically handle this. So you're pulling the commits out, and it will make sure to not call more pages of the pagination than you told it from above, because we can set this with the current count here. Also, one very important thing is you might be tempted to do, just because body is an array, to just do body.forEach and then just yield the commits. This does not work. You can only call yield inside the generator context. And this is like a stepping or something I fell over, and I was like, why is it not working anymore? You specifically have to call yield in the generator function context. So to consume this, it's again very easy. You just do a for await and do the fetch commits. And in this case, I did it with 10-stack query, and I said fetch maximum 5 pages, and then log the commit of every author. And again, if you want to be fancy, you could use RxJS or some third-party library again, and you can just pass it the generator, and then you can consume it more easily. But you know, you will ask, but will I ever encounter generators in the wild? Yeah, but actually, I had two instances where I found them. Yes. Oh, I didn't see you. I'm sorry.
So if you said yes to strict, shouldn't that already complain about using yield and array functions?
Yeah, I think it probably would, but I don't know. Maybe by IDE did something. I don't know. But you're right. Of course, your IDE in the best case should cry at you and like, oh, I can't do this. Yeah, you're right. But back to where I was. Will I ever encounter gens in the wild? I already heard some, Redux Saga or something like that, or what is it called?
Redux Saga.
Oh yeah. So that's a cool example where it's neat to know something about generators, but where I encountered them, I actually wrote some NX plugins. NX is a tool for managing monorepos, and they're actually making heavy use of generators. And I won't bore you with the details, but they have some executors where you can execute different stuffs, different functions and different CLI parts to integrate tools into NX. And what they're doing is they make heavy use of create async iterables, and they're yielding other generators. And they're doing this because you often have long-running tasks. If you have a def command, for example, where you're starting up some next application, it's a console process which is long-running. So it is very nice to have generators, because then you can just pull the state whenever you are ready to do that. So it's just it's just very neat to use it for that use case. And also, some very wise man at React Vienna just said, in Effect.js you can Effect.js. Yeah, if you don't know it, it's kind of an inside joke, but yeah, Effect.js.
Sebastian unfortunately couldn't make it today, but
it's very sad. I did this meme for him, but sadly he's not here.
If you go back, I will send it to him.
Yeah, okay. Maybe you can do like a small video.
Yeah, go for it. Let's do it again.
I'm acting. So, a very wise man from React Vienna said one time, in Effect.js you can, Effect.js, Effect.js. So, yeah, that's you, Sebastian. Very bad acting, I'm sorry, but yeah.
You will love it.
So, I again won't bore you with the details of Effect.js, but Effect.js is a meta wrapper for TypeScript, which makes it a lot more type safe, and it makes you handle some edge cases, and it's a very cool library. But they also make heavy use of the generator function, and in this case, I thought it's very, very neat, because that's what I'm assuming. I don't know it for sure, maybe you know more, but I think they're using generator functions because they have a very neat type system in TypeScript. And a generator has basically like three generics. The first one is the actual type, which is yielding. The second one is the return type, because you can also return from generator functions, but I left it out to not make it too big. And you can also give the next function some value, which you can also type. And I think that's the reason why they opted to do this. Yeah, and that's basically it. This is the end from me. So I wish you happy exploring, and as promised, I put up a page on my website where you can see all of the resources. I will put some more once I have the time. It was very on short notice, but you should find every resource there. And if you have some feedback or something, just feel free to tell me. And if there's any questions, you can ask now. Thanks for listening to my talk. Yes.
So you showed how we can for await an async generator. I assume we can also for a synchronous generator.
What do you
Or
mean?
just a regular for loop with a synchronous generator without the await keyword. Is this the
Yes,
same
yes.
syntax?
You can do a for off as well because it's just iterating over. It's just returning an iterator. So everything you can do with an iterator, you can. Yeah.
And how do I manually consume an asynchronous generator? What,
You can
do I await the next, or do I await
Yes.
the next dot values?
You await the next dot value. So
The
you
next
call
dot-
iterator dot next dot value, and
Yeah.
you put that into an await, and then
Next,
you can
I
await.
await next dot value, and then done will be
Yes.
after the await done will be evaluated.
Yes. So basically, because you have to await the value that comes out of the next value, right? So you have to await that. And you can also do a very ugly while loop again with the while not done and then do the await inside. And
Not done await
yeah.
next value.
So that's why they basically added the for await thingy into the language to make it more readable, but still I don't like it, but yeah, that's another topic. Yes?
Is it possible for you to tell us what was the case? You were talking to your handsome friend from London, that he said that you actually use generator. If you want to say it,
Yeah.
It's just
It's something. I had a system. I was heavily using RxJS back then, and I had some system where I said, you know, man, I don't like promises because they fire at the moment when they're declared. And so I had this problem where it would fire more promises than I wanted. So I needed some way to control.
It's time to go.
I needed some way basically to control how many API requests were done at a certain point, and if I had used generators, this would have been more easier because there you have the clear control flow on how many promises you want to fire, because it's super lazy and it's only doing stuff when you like yield stuff. So yeah, that's why he said, man, just use promises, just use generators. And I was like, yes. So yeah.
Generators beautiful functional paradigm, or can you also use them in classes?
You can use them anywhere actually. In classes, I actually don't know, but in objects, for example, you can just write a star before the function thingy, and then it converts that to a generator. You can easily look that up.
Mobex uses it for flows, for example. So, you can use it in classes. Mobex, for example, uses it for flows, which is like a way of not having to await, basically.
And do they have to be static methods? Because I had issues with this.
There they don't, but you declare with you can declare a function, but you call it with a wrapper. So there's probably a bit of magic going on.
Man, it was just a bad idea to introduce classes to JavaScript.
Yeah.
Unpopular opinion. Yeah.
I can yield an iterator.
Yes, you can.
Can I also yield an async iterator, like an async generator?
So basically you can yield anything, but if depending on what you yield, you then have to handle it where you consume it. So you can of course yield an async iterator in a normal generator.
Why would you?
Yeah, why
it's
would
already
you?
yield.
Yeah, but if you do that, you call next, and then the next value will give you the async iterator. So then you have to handle that.
But haven't we seen like an iterator that it breaks out the iterator in its, its parts?
The yield star does that. So the yield star
So it can
iterates over the
can I do a yield star with an async iterator then?
Yes. Yes, you can.
Okay.
So a yield star is a for iterator yield item.
Yes. So it
Or await.
yeah, it gets very common. So maybe you know now why so many people are afraid of generators. So there was a question back there.
If we have an application which heavily uses generator, is there a difference in terms of memory usage? Because the generator use should actually remember the context, because we are calling this next value But if we have a normal function or a promise, it gets into the stack, and after the execution, it's gone. But it could happen that we forget, and the generator function is not done yet, but it remains in the memory. Do you have any idea what could be the difference in the memory?
So when you think back to the file example I showed you, the only thing which it needs to keep in memory, it's the same as using closures. So anything you use to keep track of the loop and so on, but everything else is very lazy. So once you call yield, it doesn't need that anymore. So it's actually more memory efficient in this case when doing the file reading, because it only reads 10 lines and then it yields that, and then in the next execution it's gone already, you get the next lines. So I don't know exactly the answer, but I can tell you what I just told you, and there's also a lot of benchmarks online which they like profiled, like using promises and generators, and then exactly in the file reading example, they saw that it's much more memory efficient to use generators. Yeah, that's what I can tell you.
Is it also faster compared to promises? Okay.
Yeah.
Because promises are very slow. So
I mean, it depends on what you're doing. I think it's not that the promises are slow, but usually when you're doing promises, you have HTTP calls and so on. So that's the reason why it's not.
Then it doesn't matter. But if you were just, I was surprised how slow promises are compared to just using callbacks, and it's significantly slower. And I thought like maybe generators are in between, like slower than callbacks, but faster than.
It's actually a good question. I don't know the answer to that.
But the thing is, you're not using promises or generators in isolation, so they kind of complement each other.
Yeah.
If you have anything async, then if you're using a generator, you're still using promises with the generator anyway.
Oh yeah, true.
Yeah.
And the same is with callbacks, you can do the same with the callback as well.
True. So there was a question at the back.
Silly question from the blissfully unaware. What's wrong with for all?
It's just personal style. I just prefer the functional approach to use map and for each and so on. For each is not functional. I'm sorry. Yeah. Anyways, reduce. Yeah.
Some input from Redux Saga. So you can in Redux Saga you yield actually effects that do something, and this put me off that you have to yield on the top level. What I usually do is I have an array, I map the array with the effect. So the map returns the effect and then yields the array. So it's like you can keep the function style as well.
That's I will talk to you later because I was stumbling into that and I was like, there must be a better way to do this, but let's talk later. Yeah, cool. Any more questions? Yeah.
So the function star makes it an iterator. What if I?
No, it just iterates over the iterator you give it.
If I have a function star.
Yeah, if you have a yield star, it iterates.
Yeah, but the function star. So I need the function star in order to enable the yield keyword.
Yes.
What if I don't yield in that function? Is it basically then never doing anything?
Yes.
Okay.
You can also just
you can also just return, but I think then if you call next on it, it will only return one value, right?
Yes.
So, yeah.
So it's immediate. So after next, it's immediately done.
Yes.
Do I get that right?
So as soon as you call return, it's done.
Yeah.
Also, if you call throw, it's also done. Like, or if you throw an exception.
So I could wait an eager iterator by having function star immediately returning 1 without yielding.
Yes. But why
not that I want to do it, but I want to.
So before it gets more complicated.
What if?
Yeah, Yeah, but if you have more questions, I think you can ask me later or something.
All right. Then thank you very much.